Okay, let's get down to work here. New data definition, a list of numbers. This is going to be a little bit different because a list can contain any number of items. Well, by any number, I mean it can contain 5 items or 2 items or 1 item or even 0 items or 17 items. Okay, let's make a data definition for this. Now, if I just ask you informally, you can say, oh, what is a list of things? You're like, oh, it's a bunch of things. It's a bunch of things in a row, in a sequence. And I'll say, what is a sequence? Or what do you mean by in a row? What do you mean by bunch of things? And we can go around in circles for a while. What we really need is an actual definition we can use to create our code. I want to know how to represent a list inside my program, okay? And we're going to assume it's not built into the language, okay? We can do it. So here's how we're going to go ahead and represent a list of numbers. I'll give you the data definition, and then we'll work on it from there. So a list of numbers is either the empty list, which I'm going to write as tick, open, close, or it can be, gosh, here's what I'll say. It can be the empty list, or you can have a single item that you tack onto an existing list that makes a new, bigger list out of it. Okay? So I want to tack one item onto an existing list. How many pieces of information are involved with that? A new item and an existing list. How do we, if I have exactly 2 things, then I want to say, hey, I need a data structure that can hold 2 things. Oh, make a struct with 2 things in it. Make a class with 2 things in it. So make cons, I'll say cons for constructed list. I'm going to construct a list out of a individual number and some existing list of number. Okay, this is my data definition for a list. It's a union type. It's either that or that. And here's the interesting twist, of course. The definition of a list of number refers to a list of number in it. So can we go ahead and make some examples of the data? Go ahead and give me something that in a court of law you can defend follows from this data definition we just set up here. Well, gosh, there's 2 branches. One of them looks a list of numbers is that or that. Oh, hey, yeah, that very first one. So if you did not shout out tick, open, close, or you can call it the empty list, or if you just want to call it empty, we'll take that to mean the empty list. Yeah, if you didn't shout that out, yeah, well, look at the data definition and, hey, give the smart aleck answer. If I say a directory result can be the number -99, then later I ask for an example of a directory result, say -99, don't worry about anything else. Okay. Give me another example of a list of number. Oh gosh, I guess make cons, and I need to provide some particular number, 17, and some particular list of number. What existing list of number do we have already written down on the screen? Hey, the one I had in the previous line, right? Okay, so this will be another example of a list of number. And if it comes to a court of law, you can defend this, right? You say, hey, a list of numbers is allowed to be this, and all I have to prove, I have something of that form. All I have to prove that 17 is a number, and sure enough, we all agree on that. And I have to prove that this thing is a list of number. Oh, well, that's true because of line 56 in my data definition. Okay. Great, let's come up with another example of a list of number. Now, you could say make cons of 18 and tick mark, and that's fine. But that's not really very interesting. That's sort of what we've already seen. Let's go ahead and do another one. A different list of numbers that's more than this. Well, I have to start with make cons. I've already used my empty. I've already given that example, so I can't choose that one again. Make cons of 15, and now some existing list. And again, if I just, for my existing list, if I just use empty, well, not so interesting. That looks like the example I just made. Slightly different, but not fundamentally different. Hey, this was a list of data, right? We just went to court and proved that. So I can go ahead here. If I need a list of number, So if I make const and 15 and some other list of numbers, boom, well that's okay. So this will be the empty list. This is a list containing one number, 17, and this is a list containing two numbers, 15 and 17. And again, how are we constructing these lists? We're taking one number and adding it to an existing list. I think of a pile of sticky notes here. I have a pad of sticky notes, that's my list of data, and I take one more and slap it on the top. Okay, so go ahead and make one more example of the data. You can pause and then come back to compare it with mine, which is make const of 13 and something. I need to replace it with a list of number. Oh, I'll just copy paste here. There we are. So these are all examples of the data. Now you're right, make const, that sounds like a constructor. I guess we need to define struct to make this actually work. Define struct const to have two fields, right? What two fields? What is the type of the first field? Better be a number. Type of the second field? List of number. Okay. What should we call these two fields? We said this is a list that contains 17 and nothing else. This constructed list contains 15 tacked onto some other list. This is 13 tacked onto some other list. I'll go ahead and say what is the first number of the list. Okay. And then what is the one other field is the rest of the list. Okay. So we're going to go ahead and have this define struct const, and the constructor signature would look like takes in a number and a list of number. And returns, I guess it returns a const, a constructed list, which is a type of list of number. But it's not the only type of list of number. What list of number is not a constructed list? Oh yeah, yep, the empty list. The empty list is not a constructed list. Okay, so it turns out in Racket, we actually do have this data type built in. If we didn't, what we did here would be perfectly fine. This would be a weird symbol if I had symbols. I could use something like the string whoa Nelly to represent the empty list and replace, make const of 15 with make const of 17 and the string whoa Nelly. If I want to use that as my data definition, I could have. It would be a little bit weird to use a string to represent the empty list. But here's my point. If lists aren't built into your language and all you have is the ability to make new structures and union types in comments perhaps, yeah, you can make a data definition for lists. That's pretty cool. Okay, where was I? Define struct const. It turns out this actually is built into Racket. The tick open close is a symbol. It's a symbol that represents, it's just a symbol that's built in, and we call it the empty list. But there's no more meaning to it. It's no more consequential than the string whoa Nelly. I could have used whatever marker sentinel value I want to represent an empty list. I'm choosing tick open close. Okay. It turns out this define struct const is already built into Racket as well. So we can actually run this, except, well, just to make life simple or more complex, I don't know. The constructor is not actually called make const. So there is this struct with two fields called first and rest. Those exist, okay? However, the constructor is not called make const. The constructor is just called const. Okay? So really that's how we get actual things that we can actually put in our program. So I'm using the built-in struct that's built into Racket. Again, if it weren't built into Racket, I would just say make const and define my own class const or whatever. I could do this in Java and have lists even if lists were not provided with java.util. Okay, so I don't actually need this define struct here, okay, because that is built in and it looks like this. And these are examples of the data and I can actually run that, okay? So, by the way, if I have a list, how do I pull out the parts of it? Well, I use the getters, right? So what are the two getters for if I have a defined struct const and the two fields are called first and rest? What are my two getters called? Let me undo that. Imagine it was still here. consfirst and consrest. So if I give you consfirst, and I'm going to take this whole list here, copy and paste, what does that give back? Consfirst of cons13, cons15, cons17, empty. Well, this is a struct with two fields, right? The first field is 13, and the second field is this whole blah. Yeah, so that should go ahead and give back 13. Let's go ahead and run this. I have some other things later in the file that are coming up, and I'll go fix this missing file here. Okay, sorry about that. Fix that little thing. So we can go ahead and run this, and sure enough, it comes back. Oh, it gives an error. Cons-first, this function is not defined. I lied to you. The getters, they should be called cons-first and cons-rest. We've seen that, but that's for structs how they work. And this constructor should be make cons. But it's only cons to save us typing. It turns out the getters for conses are also shortened. They're just called first and rest. Okay, so not cons-first, but first. Okay, now I can go ahead and run this, and I can see, again, we go line for line, and we see here are the results. Empty evaluated empty, cons17 empty evaluated to cons17 empty, cons15 to that list evaluated to cons15, cons17 empty, and so on. This is similar to if we went ahead and said something like make book and all this arguments and just evaluated that, we'd get back and it would just show us that struct, make book of blah, blah, blah. Same thing going on here. Okay, and then we see this 13, that's the result of calling first on this big blah. What is the example of calling rest on that big thing here? So again, this whole thing is a struct with two fields. The first field contained 13, and the rest field contained, see if you can name it, say it out loud, this. There's only two, we only passed const, two different things, 13 and that orange blob. Okay, so that's first and rest. Now, of course, if I want to pull out the 15, I would say first of that thing there. So first of cons15, cons17. I could even say this here, couldn't I? First of something that evaluates to cons15, cons17 empty, which we just saw this evaluates to cons15, cons17 empty. So first of rest. First of rest, you can think of that as giving us the first item in the rest of the list. I mean, well, should think of it that way because that's what it is. So yeah, I have this list here. Take the rest of this list to get here, and then take the first thing from that. So first of rest of a list gives you the second item inside that list. Yeah. Of course, so what is first of empty list? Wait, that's an first is a selector for a construct. You have to give it a cons object. Okay, and now let's go back and appreciate our data definition and say that a list of numbers, so list is the union type. There are two different branches. Cons is one of the two branches, a constructed list. Okay, and these are different types. So cons and list are different types. Okay, every cons is a type of list by this definition, but there are some lists that aren't conses. The empty list is the only one. Okay, so that's some examples of the data and making them. So be sure you can type in a few, make sure you can go ahead and extract elements from a list of number according to this data definition. And then next we'll go and write the template for this data type. And it's going to follow from everything we've talked about before. It's going to be a template, and we're going to go ahead and say union types. We'll have two branches for the two variants here. With one of the variants happens to be a struct, so we just saw about a union with structs. So yeah, in one of the two branches, we're going to pull out the two fields. Okay, so see you next time.